Imagine this for a second. You lace up your shoes, you open your front door, you step outside, and you just start walking. And I don't mean a walk to the end of the block or even the edge of town. I mean you walk forever. Literally, you step off your porch and walk straight into eternity. It's a pretty simple premise, right? But as we're going to see in this explainer, the implications of this endless stroll are absolutely staggering.
Which brings us to the big ultimate question. If you walk forever, will you return? Will you eventually, after just an unimaginable amount of time, see the familiar chipped paint on your very own front door again? It's fascinating because it takes this huge abstract concept of infinity and anchors it right to your welcome mat. So, will the universe bring you back to where you started, or will it carry you away forever? Keep this question locked in your mind, because it's going to be our compass as we navigate through the whole shebang of infinity today.
Okay, let's dive into section 1, the shape of your path.
So, the answer to whether you'll ever see your front door again, it actually doesn't depend on how fast you walk, or even how long you walk. I mean, we've already established you're walking forever. No, the answer entirely comes down to geometry. It's all about the underlying shape of the path you're walking on. You see, space isn't just some empty void. It actually has properties. For example, if you walk a circle, think, walking around the Earth, eternity is actually remarkably small. It's finite. You conquer eternity just by knocking out a loop of a few thousand miles. Kind of comforting, isn't it? The journey always brings you back home.
But look at the stark contrast here. This circle is this cozy little loop that inevitably guides you right back to square one. But what if your path is a true, infinite straight line stretching out into endless space? Well, then the answer is a hard no. You will walk forever and you will never, ever see that starting point again. You'll just keep finding brand new, completely empty space. No looping back, no second chances. The straight line represents a pretty isolating reality, to be honest. It's essentially a one-way ticket into an unfamiliar void where home is just permanently left behind.
Now, let's see how this builds with a third, and honestly, probably the most frustrating shape of them all, the spiral. Picture a path that looks like a giant slinky toy. If you're walking on a spiral, do you ever return home? Well, no, but you get tantalizingly close. The spiral basically teases you. As you walk, you loop around, and you might pass directly above or directly below your starting point. You might look down and see your front door right there, just out of reach. But you're never going to hit the exact same spot, because on a spiral, you are constantly moving forward in both time and space. You get this cruel illusion of returning, but the reality is just continuous progression. Right, moving on to section 2, the physicist's real-world catch. So we've got the comforting circle, the isolating straight line, and that teasing spiral. But hey, those are just theoretical shapes on paper, right? What actually happens when we apply these geometric rules to the physical universe that you and I actually live in? What shape is the cosmos that you literally just stepped out into? Well, the physicist's real-world catch here is that our cosmos is probably flat. And actually, let me clarify that. When physicists say flat, they don't mean a two-dimensional sheet of paper. They mean that the three-dimensional geometry of our space operates without that grand cosmic curvature that would eventually bend it back on itself. And because a flat universe mimics an infinite straight line, the physical reality of our cosmos leans heavily in one specific direction. It behaves like an endless straight path, not a closed loop. So if you did walk forever out your front door into our universe, you most likely would not return. The universe is not a globe you can just circumnavigate. It's a vast, flat expanse that just keeps going and going, presenting you with new, empty space, literally forever.
Which brings us to our final section, section 3, the twist of time.
See, we can't just look at space here. We absolutely have to look at time. Because the moment you introduce the concept of eternity, ancient human philosophy inevitably crashes headfirst into the cold, hard mathematics of infinity. Let's look at eternal return. This is an incredibly old, deeply comforting philosophical idea. It suggests that time is cyclical, that maybe eventually the universe just completely repeats itself. If that were true, walking into eternity means you'd eventually end up exactly where you started, experiencing everything all over again. But then you have mathematical infinity, which simply means infinite time. And as we just learned, an infinite straight line never loops back. Only a circle loops, and a circle actually loops very quickly because it runs out of new space. The mathematical truth is that infinity doesn't require repetition at all. It just requires endlessness. And that beautifully illustrates the final mind-bending reality of our thought experiment. We are faced with a universe that is most likely flat, acting like a straight line, operating on mathematical infinity, where time doesn't loop, it merely stretches on and on forever. So, as we wrap up this explainer, I want to leave you with one final thought. If you step out your door into an endless expanse that never repeats and never, ever brings you back, well, in an infinite non-repeating universe, where does that leave you? It's a heavy, it's somehow beautiful thought to carry with you today. Thank you so much for joining me, and I encourage you to keep exploring, keep questioning, and keep looking up.